There are tons of weird things on Mars. Spoons, noodles, doors, even faces. Are they all really just rocks? Besides, it's not the only planet in our solar system full of mysterious things. Let's check them out. Recently, we found a strange thing on Mars that looks like a smooth, spoon-like object. It grabbed everyone's attention after NASA's Curiosity rover spotted it. The rock, with a handle and rounded tip, looks like it's floating in the rover's photo. People on the internet are puzzled about what it might be. Some are joking that it's a Martian's bowling pin, or even a shoehorn left by extraterrestrial creatures. But Andrew Good from NASA says it's not that exciting. Turns out it's just a rock shaped by the wind over a long time. These kinds of rocks with odd shapes are common on Mars. They're called ventifacts. Ventifact is a rock that can get scratched, dented, or smoothed out by tiny particles carried by the wind. You'll usually find these kinds of rocks in dry places where there's not much grass or trees to block the wind, and where there's a lot of sand blowing around. Sometimes, the wind can carve ventifacts into really cool shapes, like the mushroom rocks you can see in the White Desert National Park in Egypt. These rocks look like giant mushrooms because the wind wears away the bottom part faster than the top, making them stand tall and slim. Ventifacts aren't the only cool Martian rocks. Check out this series of surreal spikes protruding from the red surface. NASA's Curiosity rover stumbled upon them while exploring the Gale crater on Mars. They quickly caught everyone's attention. Twisting structures resembling spikes looked like some extraterrestrial doors. Even the SETI Institute, an organization focused on searching for extraterrestrial life, tweeted about the image, referring to it as a cool rock. But in reality, these are just hoodoos. These tall and thin spires occur when hard rock sits atop softer rock layers. Martian spikes are likely cemented fillings of ancient fractures in sedimentary rock, with softer material eroded away over time. Again, there are many hoodoos on Earth too. They're also called fairy chimneys or tent rocks. You can find them in places like Utah's Bryce Canyon and the Colorado Plateau. NASA is excited about these weird structures because they can help us learn more about the history of the Gale crater. There was also a rock that looked like a jelly donut. We called this rock Pinnacle Island. It was spotted by NASA's cameras. However, just 4 days earlier, it was nowhere to be seen. So how did it magically disappear? In a very anticlimactic way, it was kicked up by one of Opportunity's wheels as it traversed the Martian terrain. But there's still some mystery surrounding that jelly donut. Analysis revealed that Pinnacle Island contains unusually high levels of sulfur and manganese. Both of these things are water-soluble. In other words, there might have been some water action that created these elements in the rock. So this tiny thing suddenly caused a lot of drama, and an entire lawsuit against NASA. It claimed that the agency failed to investigate a possible fungus growing on Mars. Jelly donut fungus. But not all our findings are natural. Another puzzling discovery was this thing the Perseverance rover spotted. It's something that looks like tangled spaghetti or string. Just like the donut, this mysterious object showed up in a rover camera image and then vanished from the sandy ground in several days. It turns out that it could be debris from the rover's landing system. Perseverance landed in the Jezero crater in February 2021. It had a rough landing and accidentally scattered debris around. Some of these debris pieces have been showing up in the rover's images for a while now. The string-like object is likely a piece of shredded Dacron netting, which is a type of fiber used in thermal blankets. These blankets help regulate equipment temperatures during the super hot process of landing on Mars. It probably underwent significant unraveling and shredding due to strong forces during the landing. Thermal blankets lost a bunch of stuff back then. For example, this shiny foil piece spotted in June. The rover found it on a rock. What's remarkable is how far some of the debris has traveled. The rover landed about 1.2 miles away from where it's currently exploring. It's probably because the crash threw the debris into the air, and the Martian winds carried it over such a distance. Mars is known for its strong winds, which can move lightweight objects. However, while it's fun to stumble upon them on images, there are concerns about the debris and trash on Mars. We haven't even fixed this problem on Earth, and we're already creating it on Mars. The debris we left on the red planet is already accumulating in an area called Hogwallow Flats. Plus, the debris can accidentally contaminate the sample tubes used for collecting Martian rocks. So far, NASA isn't overly worried about this, but they're keeping a close eye on it to prevent any issues with the rovers. Now, how about not things, but animals? Curiosity caused quite a stir when it captured something that looked like a rat on Mars. Some started speculating that it could be evidence of indigenous Martian life, or even that this rodent was brought along by Curiosity. But the Mars rat, once again, turned out to be just a weird rock. It looked interesting because of the natural processes like wind erosion and mechanical abrasion. We also found some worm-looking things. Curiosity snapped a picture of a formation that looks like worms wriggling across the Martian landscape. Despite its tiny size, this formation stands out with its unique shape and rough texture. It's probably made of durable material resistant to Mars's harsh erosion. And finally, our top mysterious finding is the face on Mars. Cydonia is a region on Mars that has captured both scientific and popular interest. It's located in Mars's northern hemisphere. It lies between heavily cratered regions to the south and relatively smooth plains to the north. There's a theory that the northern plains may have once been ocean beds. Maybe Cydonia was once a coastal zone. This place is full of interesting and beautiful features that tell us a lot about the history of the Red Planet. But its most interesting feature was the Martian face. This thing gained widespread attention when it was snapped by the Viking 1 orbiter in 1976. Some believed that it was evidence of a long-lost Martian civilization. At first, NASA dismissed it as a trick of light and shadow. But after some analysis, it turned out to be, yep, another rock. We also saw a face of a bear. It was captured by the high-resolution imaging experiment camera. In an image, we can see a circular fracture pattern that looks like a bear's head, with two craters forming the eyes and a V-shaped collapse structure like the nose. The head likely formed because something heavy settled on top of an old hole in the ground. This hole was filled with either lava or mud. The nose-like feature is speculated to be a volcanic or mud vent. But why do we keep seeing these strange things on Mars? Sometimes our brains can trick us into seeing things like faces or objects in rocks and other things. But these are just illusions called pareidolia. Pareidolia is a psychological phenomenon that makes us see familiar patterns or shapes, especially faces, where none actually exist. It's because the brain encounters something it doesn't recognize or understand right away. It tries to find things that look the most like this one. So it sees random patterns, textures, or sounds as something meaningful and recognizable. That's why a chair and clothes on it seems like a super creepy human-like figure at night. It also causes you to see faces or shapes in clouds, or hear recognizable sounds and even words in random noise. It's a fascinating proof of the power of our perception, but we also should be careful with it and not let our imagination run wild.
It's staring at you, and you're staring at it. A giant eye that seems to be pulling you into an abyss. You're hovering over it in your space copter. But however scared you might be, you still need to do your job. So you send your copter down to the surface of the red planet. Right, that's where you are, on Mars. But first things first, you take a moment to remember everything you know about the fourth planet from the Sun. It's the last of the inner planets. Those are the planets that lie within the asteroid belt. They're also called terrestrial, since they're made up of rocks and metals. The atmosphere of Mars is much thinner than Earth's. It contains 95% carbon dioxide and a mere 1% of oxygen. In other words, don't even think about pulling off your helmet. Anyway, there's no time to waste. You land on the surface of the planet and find yourself in a brownish-red world. That's a good thing you're wearing a spacesuit. This place is freezing cold. The thermometer sewn into the sleeve of your suit shows minus 80 degrees Fahrenheit. Time to take your first step on the Martian surface. The planet looks quite colorful, and the hue of a particular area depends on the minerals that make up the soil. The ground under your feet is covered in fine dust. It looks like rust. The same orange dust is in the air. Good thing you have your own supply of oxygen and don't need to breathe Martian air. The layer of this dust covering the surface of Mars can be from 6 to 40 feet thick. You hope you'll avoid getting swallowed by some Martian quicksand. You start walking, feeling very light. Mars is just 15% of our planet's volume and a mere 11% of Earth's mass. It means that gravity here is much weaker. Its pull is 38% as strong as the pull of gravity on the surface of Earth. You jump up and down and then try to run several hundred feet. Ha! You haven't even broken a sweat. What makes it harder for you to explore the place on foot is that the planet's surface is rocky, covered with craters and volcanoes, old dry lake beds, and canyons. You see something huge towering on the horizon, but you try to suppress your curiosity. You'll have enough time to figure out what it is later. Suddenly, a massive cloud appears in the distance. It looks as if a huge herd of horses is approaching you. In reality, you better get back into your copter and fly away as fast as you can. That's one of Mars's infamous dust storms. They mostly occur during the summer in the southern hemisphere of the red planet. They can sometimes cover the entire planet, and you see the largest ones from Earth. You hop into your copter and set a course for the eye that scared you so much. Winding channels that look like veins run through the eyeball. But the closer you get, the less it looks like an actual eye. Soon you realize it's a crater. It's giant, almost 19 miles across. Around the crater, which looks as if it has a pupil, there are other even bigger craters. They likely formed billions of years ago. That's when Mars had to withstand multiple attacks of space rocks. But why is the eye crater darker than the surrounding landscape? Scientists think that once there was Martian water in the enormous pit. Remember those channels? They were likely carrying that water. And since the crater was filled with water, it stopped some substances and minerals from eroding away. Now, remember that towering something on the horizon? It's time to go and explore it. When you come close, you realize it's the largest shield volcano in the entire solar system, Olympus Mons. It's more than 370 miles in diameter, which is almost the same size as the state of Arizona. You tilt your head. Wow! The mountain is 16 miles high. It's also rimmed by 4-mile-high cliffs. To picture the sheer size of the volcano, let's make some comparisons. The largest volcano on Earth is Mauna Loa, towering around 2.5 miles above sea level and stretching 75 miles across. Sounds impressive. But the volume of Olympus Mons is around 100 times larger than that of Mauna Loa. The Martian giant could swallow the whole chain of Hawaiian Islands from Kauai to Hawaii. But why is this volcano so large? It might be the result of lower surface gravity and higher eruption rates. Or the reason might be the red planet's crust, which is very different from Earth's. It's static. You see, on our planet, the crust is made of 15 to 20 moving tectonic plates. As plates move over hotspots producing lava, new volcanoes form, and the already existing ones become extinct. That's why lava can get to the surface through many vents. But on Mars, the crust isn't broken into the same tectonic plates as on Earth, and the lava has nothing to do but pile in one very, very large volcano. So, how about getting closer to the enormous mountain? But once you step out of your copter on Martian soil, the ground under your feet starts shaking. Well, that's a Marsquake. But how can it happen if Mars doesn't have any actively shifting tectonic plates? Specialists from NASA are sure Marsquakes occur when energy inside the planet gets suddenly released. It leads to rock fractures and cracks in the planet's crust. Another powerful jolt, and one of such cracks opens right next to you. You fall to the ground, afraid to move, but soon everything calms down. You wait for a couple of minutes, just to be sure, and get up. Oh look! Here's a perfect opportunity to explore the insides of the red planet. The crack is large enough to send a special research robot. The planet's crust is thin and consists of volcanic basalt rock. The mantle that surrounds the core of the planet is made up of thick silicates, oxygen, and some minerals. You can probably compare it with soft, rocky toothpaste. Mars's mantle is also much thinner than Earth's. It's just 800 to 1100 miles thick. As for the planet's core, it's made mostly of iron, nickel, and sulfur and is between 900 and 1200 miles wide. This core doesn't move. That's why Mars doesn't have a planet-wide magnetic field. Unfortunately, your drone is now lost in the depths of the red planet. You leave it there and continue your exploration. Your next destination is Valles Marineris. It sounds more like an Italian red sauce, but it's actually an enormous canyon, or rather a canyon system, that runs along Mars's equator. It's as awe-inspiring as Olympus Mons, more than 2,600 miles long and over 4 miles deep. The thing is so huge, it could span the entire continental United States from the Pacific to the Atlantic Ocean. Now let's make another comparison. One of the most famous canyons on Earth is the Grand Canyon in Arizona, but it's 10 times shorter and around 4 times less deep than this canyon on Mars. Some scientists think that Valles Marineris is the edge of an enormous tectonic plate. It moves so slowly that almost nothing has happened in that region over millions of years. And the movement of this plate probably began 3.5 billion years ago. Anyway, the only thing left on your today's to-do list is to visit Mars's moons. What a nice cosmic family. Meet Mars. I bet you've met him before. These two little guys are Phobos and Deimos, Mars's small moons. But it seems like Mars isn't treating the little ones the right way. Phobos and Deimos are believed to be captured asteroids. However, Phobos is gradually moving closer to Mars due to gravity, and it is predicted that it will eventually be destroyed by the planet's gravity within the next 35 million years. I won't be around then. So, I imagine this will result in a ring of debris around Mars, similar to Saturn's rings. However, this process is a natural phenomenon and not an act of destruction by Mars. Apparently, Phobos is getting ripped apart by the crazy gravitational forces of the red planet. But wait, there's more! Phobos has these crazy parallel grooves all over its surface. We used to think that they were from an asteroid crash, but now scientists think they're actually from Mars's intense gravity pulling the moon apart. Talk about a rough ride! Scientists have this wild idea that when a little guy like Phobos gets too close to a big guy like Mars, it starts to stretch out towards it. They call it the tidal force. Phobos is predicted to get stretched out so much that it'll actually break apart. Crazy, right? And the debris from the moon will form a tiny ring around Mars, just like Saturn's rings. Now, some people thought that Phobos' tiger stripes were caused by tidal forces before, but that theory got shut down because the moon is just too darn fluffy. But now, these genius researchers ran some computer simulations and found out that maybe there's a hard shell underneath all that fluff that could create grooves on the surface. But don't worry. At the rate Phobos is going, it's going to crash into Mars in about 40 million years. But if tidal forces are already tearing it apart, it might not even last that long. However, we'll still have the chance to learn more about Phobos. NASA just picked 10 rockstar researchers from all over the U.S. to join the science working team for JAXA's Martian Moons Exploration, or just MMX mission. As NASA-supported participating scientists, they'll be helping JAXA explore the 2 Martian moons, Phobos and Deimos. And get this, they're even planning to land on Phobos and grab a surface sample. The mission is set to launch in 2024, and we'll get our hands on that sample in 2029. 7 of the lucky researchers will be using the MMX flight instruments to conduct their research. Phobos is a real oddball. It's only 17 miles wide and orbits Mars at a distance of 3,728 miles, to be precise. Now that's way closer than Earth's moon, which takes a whole 27 days to orbit us. But Phobos is in a death spiral toward Mars and is slowly falling towards the planet's surface at a rate of 6 feet every 100 years. But there must be a reason why Mars is acting that nastily, right? What if it's all just because of plain vengeance? Well, okay, picture this. Mars is minding its own business, being all hot and watery like a young Earth. It's got a sweet magnetic field that's protecting it from cosmic radiation and keeping its atmosphere nice and thick. Hey, life is good. But then, at least 20 asteroids, each the size of a small country, come crashing down on Mars like a giant game of cosmic whack-a-mole. One of them even leaves a crater that's almost 2,000 miles wide. Now imagine how Mars must feel with 2 asteroids being its moons after what other asteroids did to the red planet. All these impacts are like a massive punch to Mars's gut, and its already weak magnetic field is knocked out cold. The core gets all overheated and can't circulate properly, which means no more magnetic field to protect the planet. It's like as if you were wearing nothing at the depth of the Mariana Trench. If it were possible, you'd be defenseless and chilly. It's basically what happened to Mars. So now, poor Mars is out there in the cold, unprotected from all those nasty cosmic rays. It's like going outside without sunscreen, not a good idea. But at least we can learn from Mars's mistakes and make sure Earth doesn't have the same fate. Maybe we should start investing in some asteroid insurance. But trust me, the red planet isn't mean at all. It's actually pretty friendly. While Mars may seem to be pretty tough for Phobos, there's something that might be thriving with Mars's help. So get this, a team of scientists found a way to grow rice on Mars. Yep, you heard me right. They used MMS, not the outdated way to send pictures, but a special soil called Mojave Mars Simulant. It's supposed to mimic Martian soil. And here's the catch, Martian soil has these nasty percolate salts that can be toxic for plants. So the team grew 3 types of rice, 1 normal and 2 gene-edited with mutations that make them better at handling stress like drought or salinity. And guess what? The mutant strains were able to root in soil with 1 gram of percolate per kilometer. Take that, Martian soil. But hold up. The rice grown in the MMS didn't turn out as great as the ones grown in regular potting soil. So the team decided to mix 1/4 of the potting soil with the Martian simulant, and looky there, the plants started developing better. Now these scientists aren't just thinking about feeding Martians, they also want to see if their findings can help grow crops in places on Earth with high salinity. And get this, the whole project started when 2 researchers met for coffee and decided to try growing plants together. Well, isn't that nice? I suspect you're about to say, hey, but if you want to grow rice on Mars, you have to ship insane amounts of water from Earth, and it's not easy to quench this plant's thirst. You're right. You need about 449 gallons of water to only grow a pound of rice. But guess what? Scientists made a groundbreaking announcement at the Lunar and Planetary Science Conference in Texas. They found a relic glacier near Mars's equator. That's right, water ice on Mars, even near the equator. This is huge news, and could mean there's even more ice just below the surface. It's not just any glacier, it's a relic glacier that's estimated to be 3.5 miles long and up to 2.5 miles wide. It's like the size of a small town. It's got all the features of a glacier, including crevasse fields and moraine bands. But get this, it's not actually ice. It's a salt deposit that formed on top of the glacier while preserving its shape. So, how did this salt deposit form? Well, it turns out that volcanic materials blanketing the region might have something to do with it. When these materials come into contact with water ice, sulfate salts may form and build up into a hardened, crusty layer. Over time, erosion removed the volcanic materials, exposing the sulfates and revealing the glacier's unique features. This glacier is young, likely from the Amazonian geologic period. That means that Mars has had surface ice in recent times. Who knows what other icy secrets Mars is hiding? But hold your horses, there's still more research to be done. Scientists need to figure out if there's still water ice preserved underneath the salt deposit, or if it has disappeared entirely. And if there is still water ice at shallow depths near the equator, that could have major implications for human exploration. Imagine being able to extract water from the ground at a warmer location. That would be a game changer. So let's see what else these scientists uncover about our favorite red neighbor. Maybe someday we'll even get to visit that Salt Glacier statue in person. See you next time. Dust storms on Mars can really go crazy. They hurtle through the red planet's southern hemisphere, especially during the summer. These storms can grow and encompass large areas of the planet, as happened in January 2022. Then, a dust storm covered almost twice the area of the United States. Could it be something like this that caused one of the robots we sent to Mars to go missing? The atmosphere and climate are harsh on Mars. It's mostly a desert with strong winds and average temperatures of minus 81 degrees Fahrenheit. It drops down to minus 220 at the poles during the winter. A lander needs to be specifically equipped and very sturdy to withstand such conditions. But researchers thought the Beagle 2 could handle the difficult trip to the red planet. June 3, 2003. A team of researchers got one of their pioneering robots they were about to send to space ready. It was a small and compact lander called the Beagle 2. Its mission was to touch down on Mars and search for what the world has been actively looking for decades now: life on the red planet. Now, the touchdown was due on December 25th, but the signal never came. The team tried to contact the spaceship, but at one point, they had to accept they wouldn't be able to reach it. Some thought the landing was too difficult and complex after all, so the lander crashed. But they couldn't find any technical errors. Others had a theory that the lander may have become entangled in its own parachute and fell down to the surface of Mars. Either way, the Beagle 2 was considered missing, until 2015, when NASA took pictures of what could be the remains of the lost lander. They weren't just smashed debris, the components actually looked to be intact. The lander's remains were lying with its solar panels partially deployed around 3 miles away from the site where it was supposed to land. Apparently, the Beagle 2 managed to land successfully, but its radio antenna got blocked. That's why researchers couldn't control it from Earth or communicate with it. But no one knows exactly why it happened. Have you heard of a face on Mars? In the 1970s, one of NASA's spaceships took the iconic images of the Martian surface that showed a face-like formation, as you can see in the upper part of the picture. If you have a rich imagination, you can easily see a nose, 2 eyes, a mouth, and an unusual hairdo. Some even thought it was a monument built on the red planet by another civilization. How about some other unusual things people have found on Mars, like Happy Face Crater? You can easily see why it has this nickname. Or rocks in different shapes, a pancake, brachiosaurus, or a fish. Mars also has a waffle-shaped island on its surface. It's a 1.2-mile-wide feature you can see in the area of lava flows. It might be the result of lava pushing this formation from below. It seems astronomers have also got some images of blue dunes. It's a sea of stunning dark dunes that strong winds sculpted into long lines. They surround the planet's northern polar cap and cover a region as large as Texas. The red planet is usually known for its brown sandy dunes, so these ones certainly came as a surprise. In reality, though, they're not really blue. If you could visit Mars right now just to take a look, you'd see that these dunes appear brown and orange like the rest. And the picture is a false color image. Scientists often use false colors to highlight differences in something. For example, here it's the difference in depth. Also, the biggest valley on Mars is so large it could eat our Grand Canyon for breakfast. It's a fascinating system of canyons 2,500 miles long called Valles Marineris, and it's over 10 times as long as the Grand Canyon. Now, if you could stretch this Martian canyon, it would go from coast to coast of the entire United States. Since Mars doesn't have any active plate tectonics, no one knows for sure how this canyon formed. One theory says a chain of volcanoes located on the other side of Mars, the one that includes Olympus Mons, bent the crust from the opposite side of the planet. This powerful force caused cracks in the Martian crust, as well as activated enormous amounts of water lying under the surface. This water then emerged and carved the rock away. The force activated glaciers too, and they possibly created new pathways in this gigantic canyon system. Volcanoes on the Martian surface could have erupted about 50,000 years ago, although the most powerful eruptions happened 2 to 3 billion years ago. But the planet doesn't have active volcanoes today. Most of the heat stored in its interior during the planet's formation has been lost. So now, Mars's outer crust is way too thick for the molten rock to reach the surface. But a long time ago, eruptions formed giant volcanoes, and these volcanoes most likely had an important role in melting ice deposits, which released floods of water onto the Martian surface. Now, Mars has a thin atmosphere with a volume of gas, mostly carbon dioxide, less than 1% of Earth's. But 4 billion years ago, it was way warmer and wetter than now. Its atmosphere must have been thicker back then, too. That's why it could create a powerful greenhouse effect and trap sunlight. Mars also has a powerful magnetic field. Similar to Earth's, it formed because of the currents of molten metals in the planet's core. But unlike our home planet, Mars lost its magnetic field after its core had cooled down. And without it, the planet didn't have any protection from the solar wind, which is a stream of charged particles flowing from the sun. The solar wind pulled away most of Mars's atmosphere in just a couple of 100 million years, give or take. This is what makes those powerful Martian dust storms even more intense. Mars has a fascinating history. Judging by the planet's glaciers, Mars has probably gone through multiple ice ages, just like Earth. A team of researchers got images of about 60,000 Martian rocks. Rocks were different in size and distributed randomly, which means they probably formed during different ice ages. Glaciers hide their own stories too. Who knows what kinds of gases, rocks, or even microbes could be trapped inside? Now, if you could get into a time machine and stop at 4 billion years ago, on Mars of course, the chances are you'd see spectacular scenes of flooding. Maybe there would even be some form of life on the planet's surface. A strong meteorite impact that formed the red planet's Gale crater could be something that triggered that mega flood. After that collision, the temperatures on the planet got insanely hot. This caused the melting of all that ice that was stored on the Martian surface at that time. The flooding was so massive, it changed the geological structure of the planet's surface. It carved out big ripples, as well as waves in the sedimentary rock. Now, speaking of water, vapor has been noticed escaping the atmosphere of Mars. Also, researchers have found some evidence of water flowing on the planet's surface. There are dark streaks in the soil. They seem to get bigger in the summer and shrink over the winter. There are numerous dried-out valleys and river channels on the planet. It's possible that liquid water once flowed there. Now, most of it could be locked up in ice caps or even hidden under the surface. More and more things hint that Mars used to be habitable. Mars is the only planet we know about where only robots live. 5 rovers make up the Martian population. Those are Perseverance, Opportunity, Spirit, Sojourner, and Curiosity. These robots are there to take pictures and samples of soil and air, and maybe even find life on the red planet. And someday, we may reunite with them on Mars. Who knows? Oh, and by the way, if you really could get into a time machine and stop at 4 billion years ago on Mars, then I'd like to buy you lunch and talk about it. My treat. So imagine being one of the first people sent to explore Mars. As you're approaching the red planet, something strange and creepy draws your attention. There, yes, right there. Doesn't it look like a mammoth bear's head? What or who could possibly create a bear's snout in the middle of a crater? Unfortunately, or should I say luckily, there's nothing mysterious about the bear's head. It's just a facial pareidolia. That's a tendency to see facial features in everyday things. But speaking about the finding on Mars, should we rename the phenomenon into Bearidolia? You could see that coming, couldn't you? Alright, check it out. You see a V-shaped hill that looks like a nose. Then there are 2 craters that look like eyes. And then there's a circular fracture pattern, the head, that surrounds the nose and the eyes. Experts think that the face could be created when a deposit was settling over a buried impact crater, and the nose might be a mud or volcanic vent with solidified lava or mud flows around it. Anyway, the crater does look like a bear's face, I'll give you that. But thanks to HiRISE, the Mars Reconnaissance Orbiter's high-resolution imaging science experiment camera, another of NASA's amazing acronyms, we've seen many other crazy craters on the red planet, like smiley faces, a bird, or an elephant. First, let's have a look at the famous face of Mars. These images were first taken by the Viking orbiter in 1976. At that time, the resolution was obviously quite poor, plus the lighting was slanted, which produced the result that shocked people in the 1970s, a face carved of rock staring back at Earth. Did it mean there was another civilization on Mars that had created this monument? Nah. Look at the photo of the same spot taken by the current Mars Reconnaissance Orbiter. The resolution is much better, and the face has miraculously turned into an ordinary hill. Or look at this teeny Bigfoot, whose image was captured in 2008. I say teeny because this creature is just a few inches tall, and when the photo was taken, Bigfoot was only several yards away from the camera. And here, one curious soul zoomed in on a small rock and spotted something that resembled a gorilla. That's how some people started to believe there were apes on Mars. Yeah, really. Let me show you some more examples of imaginary creatures and faces on the red planet. Most of them come from a series of images taken by the Themis camera. Currently, it's on board the Mars Odyssey spacecraft, which only needs 2 hours to orbit the red planet, carrying some important scientific instruments. Let me introduce my happy Martian to you. This 2-mile-wide crater was photographed in 2008. The next crater chain looks like a wasp with its wispy wings of impact debris. The whole feature was probably created by a meteorite that fell at a very low angle and broke into pieces right before the impact. Now, do you see a woolly mammoth or an elephant here? Lava flows in one region on Mars left this image on its reddish soil. The region itself, called Elysium Planitia, is famous for the planet's youngest lava flows. For example, the one that looks like a mammoth most likely formed in the past 100 million years. Just yesterday. Now let's talk about love, or rather its symbol, the heart. Do you like these two hearts on the surface of the red planet? This one is actually a mesa top outlined by frost, and this heart shape is an impact crater. The hit tore away dark surface material and exposed lighter soil underneath. Then some of the material probably flew downslope, creating the heart. And this dust-covered hummingbird, can you see its long beak and head? Scientists aren't sure how this shape was formed, but they think erosion and wind played a part in its creation. These dark sand dune deposits look like a howling wolf. And here, can you see a series of interlocking gears? This image looks like the letter T, right? The right angle fracture was created by the tectonic stretching of the Martian crust. Do you think we might find other letters of the alphabet on Mars too? Why not? And now, how about another bizarre thing astronomers noticed on the surface of Mars? Is that a door to someone's house? It was NASA's Curiosity rover that sent this image to Earth. It became viral because this formation over here, see, looks like a door. Unfortunately, scientists, due to their rational minds, were quick to disappoint us. They claimed that it was just a natural part of the Martian landscape. There were several clues that made them think it wasn't a real door. For example, the opening is tiny, a mere 3 feet high. They're sure that what looks like a door is actually an opening in a rock created by natural forces, like winds and erosion. If you look at the rock closely, you may notice strata. Those are layers of silt that stand out because they're harder than the surrounding material. These strata dip here on the left and a bit higher on the right. They likely appeared around 4 billion years ago in a river or a wind-blown dune. Since the strata became visible, powerful Martian winds have eroded them even more. And look at this. See those cracks? That's how rocks weather on the red planet. This small cave probably formed when several fractures crossed the strata. A pretty large boulder might have fallen out under its own weight, and this created the door-shaped opening. This theory is quite plausible, because even though the gravity on Mars isn't as strong as on Earth, it's still strong enough to do it. Besides, see that rock to the right of the opening? It has a suspiciously smooth vertical edge. It must be the culprit. It probably fell out not so long ago. But it's not only the red planet that can boast of having unusual formations. Let's take this comet, for example. This image was taken by the European spacecraft Rosetta in 2014. Can you see a face on its right-hand side? Or the moon. Here's its famous rabbit. It sits upside down with its ears pointing downward. Some people see a man on the moon. It can either be his face or the entire body. If someone sees the whole human figure, it usually looks like it's carrying sticks. Sometimes it's a toad. To spot it, look at the top left-hand side of our moon. The toad is facing upward, see? Now look at this spinning neutron star. Such a star is a collapsed core of a supergiant star with a total mass of 10 to 25 solar masses. Except for black holes and some hypothetical objects, like quark stars or white holes, neutron stars are the densest and smallest known stellar objects. Anyway, back to this particular star. As you can see, this space object, located 17,000 light-years away from Earth, is surrounded by a cloud of energetic particles. And this image, taken by NASA's Chandra X-ray Observatory, appeared in 2009 and became viral in no time. All because many people spotted a hand-like structure among all that space stuff. NASA explained that the star was spinning incredibly fast, spewing energy into the space surrounding it. This created intriguing and complex structures, like the large cosmic hand so many people see. Now look at the Horsehead Nebula in the constellation Orion. This is a freezing cold and dark cloud of dust and gas that was first noted in 1888. This dark shadowing is created by dust, and at the base of the nebula, there are many bright spots. Those are young stars at the stage of formation. Pay attention to this extremely bright star in the top left side of the Horsehead. Its radiation is so powerful that the star is starting to erode the cloud around itself. It means that, in millions of years, the nebula might not resemble the head of a horse anymore. Well, I won't be around then. The European Southern Observatory Very Large Telescope has captured an image in which we can see the collision of 3 different galaxies. We can even observe the effect they have on each other. But the coolest thing is that, while colliding, they created a recognizable shape. Because doesn't it look like a giant space hummingbird? You know, back in the 1970s, scientists discovered a mysterious gravitational anomaly called the Great Attractor. Wait a minute, I had that nickname in high school. Anyway, it's a place in the sky that draws hundreds of galaxies, including our Milky Way. You won't be able to see it because it's on the other side of the Milky Way, 150 million light-years away. The Great Attractor actually lies in the direction scientists usually call the zone of avoidance. I have one of those too. It's my closet. Now, there's so much dust and gas in this region that we can't see what's happening there. That area blocks most of the visible light from beyond. But all that dust and gas don't block X-rays and infrared light. So, as X-ray astronomy developed, researchers could finally start to observe all the objects within that area, including the mysterious force attracting everything. But so far, no one has figured out why it's happening. Our moon may be 200 million years younger than we previously thought. Many scientists believe that the moon formed during a powerful collision between our planet and an unknown Mars-sized body. The molten dust and debris got together and formed a new object we know as the moon. The lunar crust was probably going through a process of solidifying over a couple of 100 million years. Did you know about an early magma ocean on the moon? Scientists realized it was a real thing after they had discovered big amounts of the lightweight mineral called plagioclase. This material usually crystallizes and floats to the surface of magma. Anyway, this mineral was 4.36 billion years old, which means it formed 200 million years after the first solid materials had appeared in our solar system. Thus, the theory that the moon formed during this giant chaotic collision might be true. Now, if you stand on the moon one day and leave your footprint on its surface, it can stay there for 1 million years. You'd also see the footprints of other astronauts, even though no one has landed on the lunar surface for decades now. The moon doesn't have a full-fledged atmosphere. There's no breeze or anything else that can sweep up the dust and erase the footprints. We see it as a small dot somewhere in the distance, but in reality, the sun is so big that if it were an empty ball, you could fill it with more than 1 million Earths. The sun makes up 99.86% of the mass of our entire solar system. Another enormous object in our solar system is Jupiter. It's 11 times wider than our planet. For example, Earth isn't even the size of the Great Red Spot. This enormous storm has been raging on Jupiter for more than a century. And no, it's not anchored to anything solid, since Jupiter is a gas giant. It's like a massive hurricane, oval in shape, reddish in color, and wide enough to engulf our home planet. Once upon a time, it was 3 times as wide as our planet, but over the last few centuries, it's been shrinking as well as growing taller. As for Jupiter, this gas giant is some sort of vacuum cleaner that keeps our solar system safe. Jupiter has incredibly strong gravity that eats up comets or asteroids that might potentially harm our home planet. In some other planetary systems, gas giants similar to Jupiter migrate from the position where they formed. They spiral inward and come closer to their parent stars, and as they travel, they swallow up small rocky planets. Or their strong gravitational force flings these planets out of their star systems. Luckily for us, Jupiter's gravitational force doesn't work that way. If Jupiter-like planets stay away from their stars, they keep their planetary system safe, protecting those small planets in their inner orbit. Jupiter, for instance, can change the orbits of small space bodies that come too close to the inner planets of our solar system. That's why this gas giant is a good guardian of our solar system. Now, there's a supermassive black hole that roams through space at a speed of 3 million miles per hour and leaves a trail of debris behind. Hey, I had a little brother who once did that. It's about 1 million times as heavy as our Sun and, at the moment, 2 billion light-years away from Earth. This black hole started like any other, in its own elliptical galaxy with many stars surrounding it. Supermassive black holes often form and remain in the center of galaxies. But this one got away. One theory claims that this black hole is different because the galaxy where it formed may have bumped into another galaxy at one point in the past. Sometimes galaxies merge into a new one if this happens, but not this time. Instead of merging, the black hole's galaxy passed through a way bigger one millions of years ago. That giant galaxy already swallowed up some other galaxies along the way. And since it was so large, the galaxy surrounding our supermassive black hole ended up ripped apart. The black hole at its center managed to run away with some of the nearby stars. That's what left a burning trail stretching across the surrounding space. Solar superstorms are so powerful that they can cause blackouts all over the world. Random flares coming from the sun cause solar storms, and they can really happen at any time. Back in 2012, we were lucky because the strongest solar storm in over 150 years passed very close to us. It just tore through Earth's orbit. If it had happened only a week earlier, our planet would have had to deal with tons of terrible consequences, including power outages all over the globe. Gamma-ray bursts are strong enough to destroy planets. We're talking about extremely strong bursts that mostly occur in galaxies very, very far away. If these rays are pointed directly at some space object, they can completely wreck it, even if we're talking about an entire planet. So Earth is safe for now, and we have nothing to be afraid of. A gamma-ray burst happens in our galaxy approximately once every 5 million years. Luckily, it occurs too far away and doesn't affect life on Earth. That's what I call irrelevant, but still scary. A burning ice is a thing. It may be hard to picture it here on Earth, but one strange planet called Gliese 436b is literally a burning ball of ice. It's covered with ice, but at the same time, it has temperatures of 822 degrees Fahrenheit. You can't actually see the planet burn since there's too much water on the planet. It's because of the strong gravitational force that pulls the water molecules to the core of the planet and packs them together incredibly densely. That way, water molecules can't evaporate, which is why the ice on the planet's surface doesn't melt. There are stars that can munch on other stars. These space objects are mostly smaller stars with a lower mass. They target the closest stars and begin to absorb their hydrogen fuel to boost their own mass and generally live longer. A vampire star becomes strikingly blue. It also gets hotter. This way, it seems that it's way younger than it actually is. If a star, or basically any other object, falls into a black hole, it gets stretched like spaghetti. This process is even called spaghettification.
The universe is not static. It evolves all the time and grows in all directions. It's expanding, and scientists found this out almost a century ago. And it's not at a stable rate. The more time goes by, the faster the universe expands. As this happens, stars, planets, and galaxies move farther and farther apart, which leaves more space between them. If that's the case, the universe is supposed to become colder as it expands, right? After all, it was a lot denser when the Big Bang happened, and a lot hotter. As it was expanding, space was cooling down, which created conditions for planets, stars, and other space objects to form. Yeah, that's not exactly the case now. Scientists were surprised to hear it too. But our universe is actually getting hotter. They observed the temperature of cosmic gas farther away from our home planet compared to young gases closer to the Earth. Since we measure distance in space by light years, farther areas are like going back to the past, and regions closer to us are like observing the present day. They found out the temperature of a gas in space has gone up more than 10 times in the last 10 billion years. Now, the temperature of the cosmic gas that's spread all across the universe can get to around 4 million degrees Fahrenheit. Wow! As the universe expands, gravitational force does its part and pulls gas and dark matter together. It's doing some pretty hard work there. It creates galaxies and clusters of galaxies out of them. And this process is totally chaotic. It's so messy that more and more gas heats up as all of this is happening. Space was extremely hot when it was just forming 13.7 billion years ago. What if it gets warm like that once again? Scientists are observing the situation. They found out the temperature in space increased by measuring cosmic gases using something called redshift. They generally use this method when they want to see how far away some space objects are. Those that are closer to us have shorter light wavelengths. The farther some object is, the longer its light wavelengths are. And they can now determine the temperature of a certain object from its light. On average, space is a pretty cold place. The glow that's left from the Big Bang is called the CMB, which is short for the cosmic microwave background. It's so powerful and intense, it bathes the entire universe in light. It's the only thing that significantly heats up matter. But there are many smaller mechanisms that help to heat up matter in the universe, and they could go crazy if space warms up, like stars. They emit radiation that affects nearby dust and gas. They radiate throughout the far infrared too. When a star is at its early stage, the radiation coming from it forms protoplanetary structures that look like disks. They primarily form in a single plane, and a bright central star produces spectacularly illuminated gas, and there are blue reflections of this gas. It was like that with our planetary system too. Strong energy and gravitational forces cause collisions, dust, and gas in an uncontrolled vortex that's forming planets. That's why most planets in our solar system orbit in the same direction. That's the direction this giant whirlpool was spinning a long time ago too. Active stars, colliding galaxies, stellar cataclysms, black holes, neutron stars. The universe has so many sources of energy. And when you surround normal matter in space with such an energetic environment, it heats up drastically. When you heat something up, it radiates that energy away in a certain way. In most cases, galaxies have just a couple of areas where stars are forming, at regions where gas is collapsing. A bubble that surrounds that area contains ionized hydrogen. 3/4 of our sun is hydrogen. Thanks to that hydrogen, the sun keeps us warm. In its core, hydrogen transforms into helium and causes atomic fusion. Yep, that's how our sun releases its energy. Radiation heats all that gas to thousands and thousands of degrees. At the same time, it ionizes a large number of atoms and molecules, which basically means it turns them into ions. Atoms are neutral particles, and ions are either negatively or positively charged particles. If the universe heats up, our sun might too. If its temperature hits 30,000 degrees Kelvin, it could become hot enough to ionize all those materials it had previously ejected, and it could create a real planetary nebula. This would be a nebula in the shape of a ring that forms because of an expanding gas that surrounds an aging star. As the temperature goes up all the time, hydrogen ionizes, At a few thousand degrees, this could turn the nebulae in our solar system pink with emission lines. Our sun could come to its end if it reaches the temperature of 50,000 degrees Kelvin. If you could float in space and come closer, you'd see it glow in eerie green tones because of doubly ionized oxygen. Higher energy phenomena make more galaxies collide. This heats gas even more and eventually results in X-ray emissions. What about black holes and radiating neutron stars? When they go crazy, they can shape whole galaxies, and who knows what more. Maybe we'd have more masers too. Those are natural lasers our universe produces. They arise when big populations of molecules receive large amounts of energy. By now, scientists have found the strongest, yet the most distant maser. So powerful, it's more luminous than the light 6,000 suns would produce, and in just one emission line. Maybe then we'd discover even stronger masers. That's in the case that we're even going to be here at all. Because as the universe is getting hotter, cosmic radiation is getting stronger. Not so good for life on Earth. Increased cosmic radiation could harm us. Who knows if life would even be possible on Earth in that case, or if the powerful gravitational force would pull our home planet too, and crash it into another one. But maybe life as we know it wouldn't completely disappear. Or, if that happened, it could possibly somehow find its way once again, maybe in the distant future. There's a possibility our universe could support life at its early stages. Doesn't look like that when you think of the chaos the Big Bang caused, right? But that was only in its mere beginnings. After things had settled down a bit, the dregs of enormous, earliest stars formed rocky planets. In our solar system, those are Earth, Mars, Mercury, and Venus. You can't set your foot on the rest of them since they're gas giants. Back in that time, radiation was quite intense, so rocky planets had an adequate environment to form, since it takes a lot of energy to whirlpool dust and particles and bake a planet in the end. This period of time coincides roughly with that when the first stars formed in our universe. Ancient stars were way bigger than our sun. They lived shorter though. They would have just exploded as supernovas on their end.
1.5 feet with the Earth's gravity. Verification complete. Now the simulation room will recreate Mercury.
It's so hot in here.
Yes, it's like standing next to a volcano. Your jump is 4 feet high. Now switch to Venus.
Wow, this place looks scary.
On the real Venus, everything is toxic.
I feel no difference.
Yes, the gravity here is almost the same as on Earth. Switch to the moon. Gravity on the moon is 10 times lighter than Earth's, 9 feet. The next one is Mars.
Huh? It's pretty comfortable here.
The gravity here is the same as on Mercury. 4 feet. Now, prepare for the struggle.
Huh? What do you...
There is no solid surface on Jupiter. Although Jupiter is a great deal larger in size, its surface gravity is just 2.4 times that of the surface gravity of Earth.
It's hard to even stand here.
Only half a foot. Got it. Switch to Saturn. There is no solid surface here either, but Saturn's gravity is almost the same as Earth's. Now Uranus.
It's so cold.
It's 5 times warmer here than on the real Uranus.
Seriously? My legs are numb.
1.7 feet. Gravity is slightly weaker than Earth's. That's Neptune for you. Your jumps are 1.3 feet high.
Of all the creatures on our home planet, this could be the only animal that could survive harsh conditions on Mars. The tardigrade. These fellas have another name because of their unusual looks. Water bears, or moss piglets. They live literally everywhere across the globe, from coastal dunes to mountains, from the lush Amazon rainforests to the barren landscapes of Antarctica. Some live on land, but tardigrades are creatures that need water around their bodies to enable gas exchange and generally stay hydrated. That's why they prefer soil, moss, or leaves covered with a layer of water. And since they're aquatic creatures, they usually choose freshwater bodies like lakes, rivers, and ponds. You haven't come across these cool animals before because they're only 0.02 inches long. You can barely perceive them with the unaided eye. But since they're virtually immortal, we can assume they've developed some amazing survival tactics. If we loaded them in a tiny spaceship and sent them to Mars, they'd be a little shocked at first, especially because of the temperature. Sure, they can live through a wide range, even going below minus 458 degrees Fahrenheit and up to 302 degrees Fahrenheit. And Mars might seem like a very hot planet when you see it in pictures, but the temperatures there are actually low, way lower than on Earth. I mean, it's farther from the sun and has a thin atmosphere, so temperatures there can drop to minus 200 degrees Fahrenheit or go up to 70 degrees Fahrenheit. On Earth, the lowest temperature was recorded in Antarctica. It was minus 128.6 degrees Fahrenheit, while the highest occurred in California, 134 degrees Fahrenheit. Tardigrades are also pretty resilient when it comes to strong pressure. They can take one that's 6 times bigger than the pressure at the bottom of the ocean. Now, for every 33 feet you go down below the surface, the pressure doubles. So, at a depth of 2.4 miles, the pressure is 380 times greater than at the surface. And in the very deepest parts of the ocean, it can be 1,100 times greater. The pressure on the red planet is about 6 times stronger than in the ocean depths. So I guess it's a little bit too much. It would be hard for these little creatures to adjust to such conditions. They would have to evolve through the next few generations to become even more resilient so that they could enjoy their time on Mars more. The food could be one of their main problems though. Some tardigrades mostly eat plants like moss, algae, or some flowering ones, and they like them served with a portion of bacteria. Others are carnivores that eat smaller tardigrades or other microscopic organisms. Well, they'd find nothing like this on Mars. So I guess we'd have to fill their tiny spaceships with lots of stashes of food they would be able to pull inside their tubular mouths. Now we're getting to the really tricky part: water. The red planet is a dry and dusty desert today. But come on, look at all those riverbanks and dried up deltas. Water must have flowed on its surface a long time ago. It's hard to understand where it all went, but it's highly possible most of the ancient water ended up trapped within minerals on the planet's crust. Some older research suggested that most of this water had escaped into space when the sun's radiation had ruined the atmosphere of Mars. But a new study has shown that only a little bit of water escaped, while most of it is still there, hidden and waiting for us to discover it. Also, a few years ago, researchers found signs of hydrated minerals on the slopes of the red planet, where they saw mysterious darkish streaks that seemed to flow. It mostly happens during warm seasons, since they fade when it gets cooler. These downhill flows could be evidence of real liquid water on Mars. Scientists have discovered some minerals that confirm this idea too. These minerals can lower the freezing point of water like salt does on icy roads. That's why scientists think there might be a shallow underground flow of briny water that causes these streaks. Tardigrades probably have excellent instincts, considering they can survive even in the toughest conditions. So they'd probably find water on Mars way before us. But even if they didn't do it right away, they would still have their tactics to stay alive for a while. If this creature loses 99% of its water content, it can survive by pausing most of its vital functions. It can remain in such a state for a couple of years. Tardigrades can absorb extremely strong impacts that would easily crush other animals, including us. They can withstand radiation levels so high that they could destroy a human. And even if we do send tardigrades to Mars one day, that won't be their first trip to space. In 2019, a spacecraft went to the moon, carrying thousands of tardigrades, the first lunar library, human DNA samples, and a DVD-sized archive that contained 30 million pages of information. The idea was to create archives of all the knowledge the human race had collected. But seconds before the spacecraft had to land, the mission control lost contact with it, and it crashed into the surface of the moon. The team was wondering what was going to happen with the spacecraft's cargo. After lots of discussion and analysis, they assumed that the library had survived, and even crazier, perhaps tardigrades had too. They were in this dehydrated kind of dormant state, so they shriveled up into tiny balls. They lowered their metabolism and expelled most of the water from their bodies, waiting for a better environment where they could be their best selves once again. These creatures can stay like this for decades and survive extremely harsh conditions. And this wasn't the first organized tour to space for tardigrades. In 2007, a team of scientists sent a group of these tiny water bears to orbit our home planet on the outside of a rocket for 10 days. They did pretty well, considering that when the rocket got back to Earth, 68% of these creatures were alive. Scientists don't put all their hopes only on these water bears. They keep testing if there are some other life forms that could survive on the red planet. They did an experiment called Biomex on the International Space Station. They took tiny organisms such as algae, bacteria, and other similar creatures and kept exposing them to really tough conditions in space for 18 months. This means things like huge changes in temperature, extreme radiation, and vacuum. The amazing part is that many of these tiny life forms survived these harsh conditions and came back to Earth as true space heroes. So they could probably deal with the hardships of living on Mars. Scientists studied archaea as well. Those are tiny, ancient microorganisms that have existed in salty seawater on our planet for more than 3.5 billion years. Some of their relatives from the Arctic also survived in space-like conditions. But life on Mars doesn't have to be a whole new thing. Billions of years ago, the red planet might have been a bit like Earth. It most likely had water, and that's one of the key ingredients for life. Scientists believe tiny organisms called methanogens might have thrived there. They were hiding beneath the surface to stay safe from harsh radiation. These organisms could have breathed in hydrogen and carbon dioxide, exhaling methane gas. But as they gobbled up hydrogen, which was a powerful greenhouse gas back then, they might have cooled the planet too much. So it's possible these ancient microbes are still somewhere there, trapped in ice deep below the surface. They could be in a sort of deep sleep, waiting for better conditions to wake up, or some new cool friends from Earth. How do you prepare for a long trip? You probably look up the route on Google Maps or watch a walkthrough on YouTube. Or maybe you ask someone who's been there recently. But what if you're bound for a place humans have never existed? Yes, I'm talking about our next-door neighbor, the Red Planet. NASA is planning a mission to Mars in the late 2030s or early 2040s. That's too far in the future, so why start preparing now? Well, it's closer than you think. Rookie astronauts spend at least 2 years training just to go out in space. For every hour they spend in space, they need to spend 10 hours underwater on Earth. This training only applies to spacewalks and the International Space Station. So far, some 600 people have been to space, but humans have never set foot on Mars. Traveling to this planet will require a different kind of training. Is there a region of Earth that closely resembles Mars? The Apollo mission's astronauts trained in Nevada. This is where Neil Armstrong and his fellow astronauts got a sense of what the surface of the moon would feel like. But Mars is different from the moon. It has gravity and an atmosphere. In this aspect, it resembles our own planet. Just one country, to be more precise: Iceland. NASA used this island in the far north of Europe as a testing ground for its 2020 Mars mission. And no, the mission didn't involve humans landing on the red planet. Just a small rover looking for signs of life. But the high-tech robot still needs some practice. Let's do a little test of our own. Compare the landscapes on Mars and Iceland. Are you struggling to spot the difference? Good. That means that scientists have picked the ideal training grounds for the upcoming Mars mission. An area entirely barren and devoid of life. That's how one researcher involved in the mission described Iceland. And this description perfectly matches the conditions future astronauts will encounter on Mars. But what's so special about Iceland? There are valleys that were created by volcanic eruptions. The island is still young in geological terms. Simply put, it's still forming. Lava flows, water, volcanoes, raging winds. Iceland has it all. The country's slogan is the land of fire and ice. The island's population is just above 350,000. For comparison, the city of Cleveland in Ohio has more residents than the entire country of Iceland. But the size doesn't always matter. Remember Euro 2016? When England lost to Iceland 2-1, their players became stars overnight, but Icelanders are closer to the stars than you think. The country has a space agency. Yeah, you heard it correctly. Now, this agency actually consists of 2 people who are trying to promote Iceland as a terrestrial analog to Mars. In short, this means that Iceland looks a lot like the Red Planet. The local duo wants to get space scientists to choose Iceland as a training ground for future astronauts. Their biggest argument is that it's cheaper. Sending people and equipment into space is expensive. Duh! According to Elon Musk, SpaceX launches cost around $2 million. That's way less than a typical NASA launch. A large portion of space research takes place back on Earth. Antarctica is ideal for studying cold and desolate places in outer space. Hawaii is perfect for exploring lava tubes and the composition of rocks. Just imagine the logistics behind going to both of these regions at the same time. This is where Iceland comes into play. It has diverse habitats that are relatively close to each other. So what exactly will future Mars-bound astronauts do in Iceland? To answer this question, let's travel back in time. Nevada wasn't the only place NASA's astronauts visited more than half a century ago. They prepared for walking on the surface of the moon in Iceland too. Their primary objective was collecting rock samples. These can mainly be found near volcanoes and lava fields, and Iceland has plenty of those. Around 60% of the local landscape is rocky and rugged. This makes the island the size of Kentucky feel like another planet. Add that to the fact that 80% of Iceland is uninhabited, and you get the perfect playground for astronauts. And there's another similarity with Mars. In summer, it can seem as if the sun never sets in Iceland. Locals go shopping at 3 a.m. In June, for example, the night can last only 2 hours. Sounds like a perfect open-air party destination. Well, not really. Who would want to party at a freezing temperature of 42 degrees Fahrenheit? That's the average low air temperature in June. Future astronauts spent weeks in Iceland, trying to adjust to these strange conditions. This helps them prepare for the long days on Mars. This is not a figure of speech, since days on the Red Planet are longer than the ones on Earth by 40 minutes. That's not much, considering the length of days on other planets. On Jupiter, a day is over in just under 10 hours, while a day on Venus equals 243 Earth days. But let's first land on Mars and then think of other planets, shall we? Have you been doing some math in your head? If one day on Mars is 40 minutes longer than on Earth, then how long is a Martian year? Nope, I'm willing to bet your calculations aren't correct. You forgot to factor in an important detail. The planet is farther from the Sun than Earth. This means that a year on Mars lasts 687 days, nearly twice as long as a year on Earth. Sorry, future astronauts, you'll get a birthday cake once every 2 years. There's another minus to the Red Planet, literally. The planet's average temperature is minus 76 degrees Fahrenheit. Makes Iceland's climate feel like the tropics, huh? Despite these extreme weather conditions, scientists believe that water once flowed on Mars. And where there's water, there's life. That's why NASA scientists lowered the tiny rover in the middle of a crater that they suspected was once a lake. This is where it stands the greatest chance of finding evidence of life. What about life forms on Mars? Looks like it's not science fiction. The planet has polar caps like Earth, and that's not all. Scientists believe they've even detected snowfall on Mars. Its atmosphere is 100 times thinner than that of our planet. It isn't a breath of fresh air, but it isn't extremely inhospitable like other planets. On Venus, it rains acid, and the temperature is high enough to melt lead. And on Jupiter, there are gigantic storms that rage on for centuries. Makes you fall in love with the blue planet all over again. Even Iceland sounds fun at this point. You might even want to learn Icelandic. If you're successful, then you can even read Old Norse, the language of the Vikings. And you'll know 100 words for wind. This will come in handy as wind speeds on the island can reach up to 40 miles per hour. Out in the open, you have to hold on to a fence or a signpost to stay on your feet. Iceland's climate will make you think twice before moving there. But for astronauts preparing for another world, this place is perfect. Iceland is equally impressive underground. In fact, the island might hold the key to sustaining human life on Mars. The surface of this planet is not very hospitable. The soil is poisonous and abrasive. It can easily cut through an astronaut's suit. But underneath the ground, the living conditions are more tolerable. And Iceland has a real-life model of this potential underground dwelling: lava tubes. Long tunnels carved out by lava making its way to the surface. These maze-like corridors are perfect human habitats. And they're cost-efficient. Nature had already built them for us. Future astronauts can walk through similar lava tubes in Iceland. Who knows? One day their cautious steps might turn into giant leaps for mankind.
NASA made this cool rover called Curiosity and sent it to Mars to see what else we can find out about the red planet, the one that will possibly become our next home. Curiosity has been exploring the surface of Mars, taking measurements and gathering data about the planet for more than 10 years. And good old Curiosity stumbled upon some interesting wave-rippled rocks in the region of the Martian surface that was kind of expected to be drier. Scientists believe this area was actually a lake bed. It might be the bottom of a dried-up lake and all that sediment and other things that have accumulated there. All this can give us some important clues about the history of the lake. For instance, the types of organisms that might have lived there, how deep the lake was, how long it was there, and similar stuff. These wave-rippled patterns tell us that these rocks may have formed when strong Martian winds were moving the water in this big ancient lake. You know that specific sound you can hear when you're holding a seashell to your ear? You actually hear it because of the way the air gets trapped inside the shell and moves against its walls. The air cannot escape, so it vibrates at frequencies that depend on the size of the shell. In other words, you have a feeling you hear the sound of waves hitting a shore. That's Mars in my imagination now, a spot where you can still hear the long-lost sound of waves crashing against the shores of mysterious gigantic lakes. During its mission, Curiosity also came across a metallic object which turned out to be a meteorite. This unusual rock that came from space is made of nickel and iron. Its name is Cacao, and it's about the size of a small car, 6.5 feet long, and weighs over a ton. This is an important discovery because we don't often find metallic objects on the Martian surface. Most of the rocks there are made of basalt or some other volcanic materials, so that chunk of metal could tell us more about the history of Mars and how it formed. Plus, it definitely stands out. The surface of Mars is red from oxides, while Cacao is metallic-looking and dark gray. It's rounded and smooth, too, which means it once passed through Mars's atmosphere. There have been other robots exploring Mars, too. For instance, NASA's Mars Reconnaissance Orbiter, MRO, stumbled upon circular sand dunes. Sand dunes are usually very common on the red planet. They come in many different shapes and sizes, but circular ones like these are really rare. They consist of dark sand with light-colored material surrounding them. And the cool thing is that these dunes are arranged in a specific pattern, similar to the spokes of a wheel. It could be because of the way the winds blow. But back to our buddy, Curiosity. It's been exploring many other interesting things, like oxygen levels in the Martian atmosphere. The levels change depending on the season. There's more oxygen in the spring and summer. It's still not clear why, though, and of course, even that is not enough for us to really breathe there. The concentration of oxygen on Mars is 0.1%, which is about 100 times less than the concentration in Earth's atmosphere. The atmosphere of Mars is mostly made up of carbon dioxide, with traces of other gases. Curiosity was so good that it also decided to analyze the age of rocks it found. It seems they're much older than we previously thought. Some of them date back more than 3 billion years. Curiosity found organic molecules in soil samples too. These molecules are basically building blocks of life. Now, this doesn't prove there's indeed life on Mars. It's just one of the things that suggests there might have been some form of life a long time ago. Curiosity discovered potential evidence that there might be a large reservoir of liquid water beneath the south polar ice cap, probably very salty and full of different minerals. This high salinity is the reason why this water could remain liquid at temperatures well below freezing. It would be cool to have some sort of subsurface ocean to take a dip in, especially when these crazy Martian winds are raging on the surface. And it would be great to have something that would protect us from those insane radiation levels on the red planet. There are some pretty toxic chemicals and salts in the Martian soil, which can be really bad for humans. Astronauts could potentially end up being exposed to these toxic chemicals, either through direct contact with the soil or by inhaling dust that contains these salts. Also, these substances could be a problem for growing crops. This is a really big discovery for long-term missions to Mars, because astronauts would need to be able to grow their own food so they can survive while there. Another thing that favors the idea of potential life on Mars is discovering methane there. Methane is a very important finding because usually living organisms produce this gas. So, where did it come from if not from them? In reality, there are a few possible explanations for that. One is the geological activity of underground reservoirs. Another idea is that meteorites brought methane to the red planet. What's interesting is that levels of methane are higher in particular areas. So, yeah, I don't know about you, but I'll stick to the theory that it comes from living organisms. Now, it's possible that volcanoes on Mars are still active. We know there are many extinct volcanoes on the red planet, but we've never found enough evidence to prove that some of them are still alive. Scientists studied volcanic deposits and found out that some volcanoes could have erupted maybe 50,000 years ago. Before that, everyone thought the last eruption happened 3 to 4 billion years ago. If you could compress the geological history of Mars into just one day, this would be like having an eruption a second ago. So, you never know. There might still be magma bubbling in secret under the Martian surface. All the future generations that might end up building their life there could really have some fun. Mars turned into a cold and barren place that can't really support life over time. And one of the main reasons for that was losing its atmosphere. The red planet used to have a much thicker atmosphere, similar to Earth's. One major reason for that is its relatively weak magnetic field. Earth's magnetic field helps protect our atmosphere from the solar wind, a stream of charged particles that comes from the sun. Without this protection, Mars had nothing to help it confront this insanely strong force that eventually took away most of its atmosphere. Another factor that played a big role in the loss of Mars's atmosphere is its relatively low gravity. Because Mars has weaker gravity than Earth, it's easier for gas molecules to escape into space. So Mars probably used to be more similar to our home planet. But with its current thin atmosphere, it can't keep any heat, which makes it very cold and very complicated for us to explore. But maybe it's better for us that we didn't visit the red planet back in its old times. There's this story about an ancient mega-flood that might have happened there. So yes, the red planet probably used to be a wetter and more hospitable place than it is today, with beautiful flowing rivers and amazing lakes, ponds, and other bodies of water. And some research showed evidence of large channels carved into the planet's surface. These channels are way bigger than any we previously found on the planet. They suggest this megaflood happened billions of years ago. Perhaps it happened as a result of different factors, like volcanic activity, melting ice, and the release of carbon dioxide from the planet's crust. The flood may have created some temporary pools of water, too. Hopefully, it will mean more interesting clues for finding traces of microbial life. How about that?
Imagine a world where the red, barren landscape of Mars is transformed into a lush and verdant garden. A world where water flows freely, carving canyons and creating lakes and oceans. Can we achieve such a world by pouring the Earth's water onto the surface of Mars? And don't rush to say no. Let's explore this possibility. Alright, let's say we could magically transport all of the water on Earth to Mars. This supersized game of water pong would be crazy in both engineering and logistics. So how do we even do that? First of all, we're talking about millions and millions of gallons of water, which is no small feat. We would need some really big tanks to get all this water off the Earth. We would also have to figure out how to launch it all into space. This would require some serious rocket technology, as well as a lot of fuel. We could probably create an entire fleet of spacecraft specifically designed for the task. Just imagine that! A fleet of giant water tankers packed with tons of carefully harvested water, blasting off from Earth's surface and hurtling through space at unimaginable speeds. Wouldn't that be a cool sight? Now, another way. Probably a better one would be to launch a large number of smaller missions over time, each carrying a smaller amount of water until enough of it has been transported to Mars. So, let's say we manage to do all that. What happens next? After we get to Mars, we'd need to distribute this water all across the planet. We could use a network of underground pipes or some special drones to transport the water to different locations. This is just some basic things, and as you can see, we already need a lot of planning and resources. Moreover, a crazy operation like this would require a massive coordinated effort from scientists, engineers, and space agencies all over the world. And let's not forget about the costs. No wonder that scientists don't really consider it a viable plan. But the scale of this operation isn't the only problem. Hypothetically, let's say that we figured all that out and poured the Earth's water on Mars. Now what? Well, believe it or not, it would be almost completely useless. Our main challenge will be the atmosphere and current climate of Mars. Mars is a dry desert with an atmosphere that's only about 1% as thick as Earth's. This means that any water poured onto the surface would quickly evaporate. It would be pretty hard to create a stable environment when the entire lake can go poosh in a matter of seconds. And if the water doesn't evaporate, then, on the contrary, it will turn into ice. Mars' surface temperature is well below freezing. Thin atmosphere only makes things worse. Another challenge is that Mars has a very weak magnetic field, which means it has little protection from the solar wind. Solar wind is a stream of charged particles that are constantly flowing out from the sun. These winds are pretty dangerous. They can strip away any water that's put on the Mars surface. Also, the solar radiation on Mars is much stronger than on Earth. This would make it even more difficult to maintain any liquid water there. And finally, don't forget that we also need to purify this water to remove all the bacteria before drinking it. But let's not give up. If we stay super optimistic, we can still try to solve these problems. Basically, we need to find a way to maintain liquid water in one place for a long time and make sure that it doesn't freeze or evaporate. So how do we do it? There are a few ways we can go about it. Number 1, insulation. We could wrap all the water containers in insulation materials, like foam for example, or some reflective materials that can help to keep the water from freezing. Number 2, heating. We could use various heaters and devices to keep the temperatures above freezing, even thermal blankets. Although this would require a lot of energy and would be a difficult task. Number 3, underground reservoirs. We could dig a large hole and cover it with a transparent material to allow sunlight to pass through. This would help keep the water warm and insulated. Number 4. Salinity. Adding a small amount of salt or other dissolved minerals to water can lower its freezing point. Although we'll need much more salt for things like lakes, and this method isn't the most efficient. And finally, number 5. Building a greenhouse. We could build a greenhouse or some other structure that can trap heat and create a more Earth-like environment. This option is probably the best one. After all, a greenhouse would also help us to grow various plants or other organisms. Yay, life! Alright, great. Let's say we've discovered some way to store water on Mars and keep it there in a liquid, lukewarm state. What now? What impact would this have on Mars? Actually, this would be great. If we were to pour all this water on Mars, it could have drastically changed the climate of this cold, red desert. First of all, we could create a so-called greenhouse effect. It's when gases in a planet's atmosphere trap heat, causing the planet's temperature to rise. And yeah, this is pretty bad for Earth, but for Mars, whose temperatures jump between 70 and negative 200 degrees Fahrenheit, it would be awesome. This could cause the atmosphere to thicken and lead to the melting of the polar ice caps. Wouldn't that be awesome? Mars would begin to gradually turn from a lonely desert into Earth 2.0. It also means that the planet's atmosphere will change. For example, the weather patterns. Clouds could form on Mars, rains would begin to fall. And rains, as we know, transfer water from one region to another, which would mean they could water plants if they appeared on Mars. But all of this is pure speculation. We can't be completely sure what kind of impact pouring water on the Martian surface would have on the planet's climate. Perhaps, to create this greenhouse effect, we would need much more water than what we can transport. But if despite all these challenges, we had succeeded with our mission and made Mars much warmer and moist, could life have been finally born there? Unfortunately, that would still be pretty unlikely. Yes, water is very important for creating life, but that's not all we need. The composition of the Martian soil isn't very conducive to supporting life. The soil is mostly made of minerals called regolith, which are composed mainly of dust, sand, and other materials that aren't very good for plants. Theoretically, we could terraform Mars. Terraforming is a gradual, slow change of the planet so that it becomes suitable for our life, but this would be a very complex, long, and costly process. Oh, and by the way, what would happen to our Earth after all that? We took quite a lot of water, didn't we? From Earth's perspective, transporting water to Mars would require an enormous amount of resources, including energy and different materials. And the amount of water we'd have to spend would be staggering. The loss of such a large amount of water from Earth's own reserves could have a significant impact on our planet, especially in areas where water is already scarce. So basically, this is a really bad idea, no matter how you look at it. Yeah, it may sound interesting, but it's not a viable plan at all. It would require too many resources, too much money, and it wouldn't even be worth it. That's why scientists and space agencies don't consider this idea seriously. Besides, there are many other more realistic and achievable goals in the field of Mars exploration. For example, we can keep studying the planet's geology, atmosphere, and potential for past or present life. These studies would help us to find some resources that could support future human exploration. Overall, we need to answer many more questions about Mars before we even begin to consider colonizing it. So let's keep an eye on scientific news and updates.